All right, let's talk about something that you use every single day, probably without even realizing it. It's the unsung hero that makes our modern digital world possible. We're talking about the load balancer. So what is this thing, really?
To get us started, I've got a question for you. Think about a crazy Black Friday sale online, or a massive new video game launch, or maybe the season finale of a show the entire world is watching. From a tech standpoint, what do all of these have in common?
Yep, you got it. They all create this huge digital traffic jam. All of a sudden, millions of people are rushing to the exact same website at the exact same second. And if you don't have the right system in place, that traffic jam leads to one thing: a total crash.
And that gets us right to the heart of the matter. It's what we could call the problem of one, trying to serve everyone with just a single resource. To really get this, we're going to use a pretty simple analogy. I want you to picture your website as the hottest new restaurant in town. But here's the catch. It only has one table and one waiter. Now, what happens when, bam, 100 hungry customers all show up at once? You get a line out the door, that poor waiter is completely overwhelmed, and pretty much everyone leaves angry and hungry. That single waiter, that's your single server. It just can't keep up.
So how do you fix that? Well, you could hire more waiters, sure, but what you really need is a smart, super efficient host at the front door to manage the entire flow. And in the tech world, that smart host is our load balancer.
So technically speaking, what is it? A load balancer is a system that does exactly what its name says. It balances the load. It stands at the front gate, takes all the incoming traffic, and then intelligently spreads all those requests across a whole group of different servers. The goal? Make sure no single server gets buried in work.
So why is this so important? Well, first up is scalability. This is huge. As your website gets more popular, you don't have to rebuild everything. You just add more servers to the group. Then there's high availability. If one of your servers suddenly goes down, the load balancer just stops sending traffic there. You, the user, never even notice. It also massively boosts performance by making sure no server gets overworked, and it's great for maintainability because engineers can take a server offline for an update and nobody's service is interrupted.
But how does the load balancer actually decide where to send each person who shows up? It's not just random. A good host doesn't just point people to any old table. They have a strategy, and a load balancer has a whole playbook of strategies to choose from.
At a high level, the process is this really elegant four-step dance. Step 1, your request arrives at the load balancer. Step 2, it instantly makes a decision about which server should get this request. Step 3, it does a super quick health check just to make sure that server is ready to go. And Step 4, it sends the request on its way. Simple, clean, and incredibly fast.
The most basic strategy in the playbook is called round robin. It's as simple and fair as it sounds. The first request goes to server 1, the second goes to server 2, the third to server 3. And once it hits the end of the line, it just loops right back to the start. Just taking turns, one by one.
But let's be real, not all servers are created equal. You might have one brand new, super fast server and a couple of older, slower ones. That's where weighted round robin comes in. It's like telling the host, hey, see that amazing chef over there? Send twice as many customers to her section. You just assign a weight to your more powerful servers so they get a bigger piece of the action.
And the strategies get even smarter from there. Take a look at these two. The least connections algorithm is just common sense. It sends the new request to whichever server is doing the least amount of work right now. You know, just like a host gives the next table to the least busy waiter. Then you have something called IP hash. This one makes sure that you always get sent back to the same server every time you visit. It's like a host who remembers you and always seats you at your favorite table.
But here's the thing. A modern load balancer does way more than just direct traffic. A really great restaurant host does more than just seat people, right? They've got a whole toolkit of other skills, and so does the load balancer.
First up, health checks. This is absolutely crucial. The load balancer is constantly pinging its servers asking, hey, you good? You still online? If a server doesn't answer back, it's marked as unhealthy and the load balancer immediately takes it out of rotation. It's just like the host making sure a table is actually clean and ready before seating someone.
Next up is a really clever one called SSL/TLS termination. Now, all that security stuff, the little padlock in your browser that makes a connection secure, it actually takes a lot of processing power to handle. So the load balancer can do all of that heavy lifting right at the front door. This means the back-end servers get simple, clean traffic and can just focus on their main job. Think of it like the host taking everyone's heavy winter coats at the entrance so the kitchen staff can just focus on cooking.
And finally, we've got sticky sessions. This is all about making sure that once you're talking to a specific server, you keep talking to that same server for your whole visit.
This is so important for things like online shopping. You add something to your cart and the system needs to remember that. Sticky sessions make sure you're always having that conversation with the same waiter so nothing gets lost.
So when you put all of this together, the smart traffic routing, the health checks, the security offloading, the sticky sessions, you really start to see why the load balancer is the true unsung hero of almost any big online system. And this is not just some abstract theory. This is the magic that lets e-commerce sites survive the absolute chaos of Black Friday. It's what allows streaming platforms to launch a global premiere to millions of people at the exact same time. And it's how complex systems, built from hundreds of little microservices, can all work together seamlessly.
You know, there's a quote that just hits the nail on the head. A load balancer is often at the heart of any modern distributed system. It's not just some optional add-on, it's the very core that makes the speed and reliability we expect from the internet even possible.
So, when you think about it, a load balancer wears a lot of hats. It's the digital traffic cop, preventing gridlock. It's the smart restaurant host, making sure everyone has a smooth experience. And really, it's the silent guardian, working 24/7 behind the scenes, keeping the internet's busiest intersections flowing.
And that leaves us with a final, kind of big thought. As engineers, we've gotten really good at managing these incredible waves of traffic. It's an amazing achievement. So what's next? What's the next great mountain we have to climb to build even bigger, even better, even more resilient systems for the future?